Hi friends, welcome to follow up. Let's have a look at a newly appeared problem 2760, longest even-odd subarray with threshold. In this video, we're going to explain a solution based on dynamic programming, or we can see just a for loop. So here, the problem statement is as follows. So we are given a zero-indexed integer array called nums, and an integer called threshold. So we want to find the length of the longest subarray of nums starting at index L and ending at index R that satisfies the following condition. First, the start position element is even, and then the numbers alternating in even and odd. So for all indices and all, in other words, all the elements, so they are bounded above by the threshold value. So we want to find the longest length of such subarray. So here in the note, it explains what's a subarray. So here the subarray is to be distinguished with subsequence, right? So here are three examples. In the first example, the output is 3. So the threshold value is 5, right? So we can consider 2, 5, 4, right? And in the second example, threshold value is 2, but we cannot start from index 0, so we can only include this 2, so the output is 1. And in the third example, the threshold is 4, so we can consider the subarray 2, 3, 4. We cannot include the 5 because 5 is out of bound, right? So the additional assumptions or constraints are the following. First, this nums has a very small length. Here is 100, and the numbers are in between 1 and 100. It's also small, and the threshold value is also bounded above by 100. So due to the problem size here, so essentially we can try maybe put a false. So in this video, what we are going to explain is a dynamic programming solution, or we can see it's a strategy. It's just a for loop, or just and mainly as how we interpret that. So here, what I'm going to do is that I'm going to define this dpi as the length of longest valid subarray ending at index I, right? And then what we just need to return is max dp, right? So here dp is a 1D list or 1D array. So this is going to be our main logic. So now let's do the coding, and in between we walk through the logic. So here, first I'm going to get the length of this nums array. So this is just for convenience, right? Then I'm going to initialize a dp table, so times m, right? And then first we're going to set dp0. Let's see, set dp0. So in other words, we want to check ending at the first element if what's the length of the valid subarray. So essentially we just need to check if the first element is bounded above by threshold, and also it's even, right? So here I changed the threshold to be s just for convenience of typing, right? So basically, if nums 0 is even and nums 0 is bounded above by the threshold value, so we're going to set dp0 to be 1, right? Notice that this nums list is not empty, right? So we can directly do this. And then what we are going to do is to set up the all the other dp elements. So because we want to return the max, so we can actually do this. So we introduce a running variable called result, which is originally set to be dp0. And then when we set each of the dp elements, then we just make a comparison with this running variable to make the larger one, to choose the larger one. So then here, let me maybe write it like this. So this is the running variable for getting the result, the return. So next, basically DP update, right? So basically for I in range 1 up to n-1. So here we are starting from index 1 because we have already set DP 0, right? And then also because I is starting from 1, so i-1 is inbound, right? So first we need to check if the nums at this index is larger than s, then we just leave the DP element at 0, right? And then we just consider the case this is less than or equal to s. Then we consider two cases. First is if DP i-1 is 0. So in this case, either nums I is out of bound, or so the previous two numbers, if they have, are two odd ones, right? So in other words, elements at i-1 cannot be used as a start, because here, if we can, so the DP i-1 is at least 1, right? So in this case, we just need to set the DP, check whether we can set DPI to be 1, right? So this is nums I, so it's first should be less than or equal to s, and nums I should be even, right? So in this case, we are going to set DPI to be 1. So this is the first case. So otherwise, right, so the else block, we just need to keep DP0 to be 0, right? We do nothing. And then let's consider the else. In the else block, it means that DP i-1 is greater than 1, right? So either it's a beginning, so in other words, nums i-1 is even, or it's odd, but it's not, it's corresponding to one part in a valid subarray. So now let's do this check. So in this case, so we are going to check if the nums i-1 and nums at I is alternating in even and oddness. So this condition means that they are alternating in even or odd. So in this case, so because we can extend the previous valid subarray by adding this nums I, so the length will be DP i-1 plus 1, right? So this is the case. Another case, if they are not alternating, so we just need to check if we can use nums I as a start, right? So if they are both odd, right? So we just leave DPI to be 0. So now let's check if nums I modulo 2 is 0, right? If it's 0, we just set DPI to be 1. So in this block, this if block, so we set up the DPI up to the current index I, and then we just make a comparison, right? Result, previous state, and DPI. Or if we like, we can just first finish updating all the DP tables, and then we do not use this running variable, but we just return the max of the DP table. So, but this way, due to the way of introducing a running variable, we can return this result variable state after we do the for loop. So this basically forms a complete solution format for this problem. So I would say let's first do a test. Yeah, it passes the first example. Now let's look at the last example just to check, right? So the threshold is 4, right? So we should return 3. Yeah, this is 3. So now let's look at the generic case. Yeah, it passes all the generic cases. So with that said, basically that's about it for this problem. So this problem is marked easy by leetcode. However, this problem is interesting, right? So here we are using DP essentially, or if you, according to the hint, maybe you can try using brute force and check every start and end corresponding to one subarray, and then check if they are alternating in oddness and evenness, and then check if they are bounded above by s. That's also a possible way, but here we used DP. So in this DP solution, so there are two requirements, right? So one is even and alternating, right? So this relation is considered the relation between neighboring elements, right? So another one is bounded above by a value. So this actually for each and every element. So we need to take into consideration these two requirements. So this is the one comment. Another comment is that you can see compare this problem with the problem of finding largest subarray sum, right? So largest array sum for that kind of problem. So there's a algorithm called condense algorithm, right? It's good to make a connection too, right? So check also condense algorithm. So the condense algorithm, so though it bears a name, it's also a case of DP solution, or we can see it's just a for loop. So with that said, that's basically about it for this video. So here we provide one format of solution aiming to explain the logic. So you are left to improve or shorten the code or write other solution formats. With that said, that's it. Thank you.